Okay, well, today we're going to continue our lesson on even and odd functions, not to be confused with even and odd numbers. So let's just read the definitions of it. A function y equals f of x is even when f of negative x equals f of x for each x in the domain of f. So last time we didn't really focus on how it looks in the equation. We focused on how it looked as a graph. Let me remind you that. And it tells you this. The graph is even if the function is symmetric about the y-axis. So something would be even if it was symmetric, meaning whatever's done to one side, the exact same thing's being done to the other side. These are examples of even functions. And then we said the function is odd when f of x, or when a negative f of x is equal to a negative f of x for each x in the domain of f. The graph of an odd function is symmetric about the origin. The graph is symmetric about the origin when it looks the same after reflection in the x-axis and then in the y-axis. There's two reflections. Again, this is just a reminder. So for something to be odd, there'd be two reflections. So if something is on one side of the y-axis, it would reflect on the other, but it would reflect again, going downward. So that's why they say it's reflecting around the origin, this center part here, because it reflects this way and then it reflects downward, and it would look like this. And that would be an odd. Okay, that was last video. So today I want to focus more on this equation part of it. Not so much the graphing, but the equation. So it says determine whether each function is even, odd, or neither. And there's three questions here. Here's what you need to know. If f of negative x equals f of x, it's even. If x of negative x equals a negative f of x, it's odd. So notice in both of these examples, they're both odd here, but one is, they're both negative here, but one is positive and one is negative. And that determines if it's odd or even. So let's work one out. We'll do the first one here. F of x is equal to 2x. So the first thing we're going to do is we're just going to write the function, which is already written. And then the next thing we're going to do is substitute the x for negative x. So if we do it to one side, we have to do it to the other. And the reason we're doing that is to determine if it's even or odd. They both have a negative x, right? An f of negative x, an f of negative x. So we're going to turn this to an f of negative x, but we just have to do it to the other side too. It's essentially multiplying the x by a negative 1, right? To both sides. Okay, so the first step we did was we substitution of x to negative x. That would be step 1. So the next step would be to go ahead and simplify this. So you'd have f of negative x. If you were to multiply that, it equals a negative 2x. And then the last step is to do substitution. So we simplified it. And then we're going to do some substitution here. So I want you to see what's happening with the substitution. We're taking just the 2x, leaving the negative, and we're going to substitute what that 2x equals. And how do we know what it equals? Well, up here, it tells you what the 2x equals. The 2x equals f of x. So we can take this 2x out, and in its place, put f of x. So you'd have f of negative x equals a negative. Instead of a 2x, you're writing f of x. Okay, so we did substitution. Those are the 3 steps. And now we can answer the question, is it odd or even, just by looking at our chart here. If we have a negative f of x equaling this here negative f and then times x, you can see that it's odd. So this is an odd function. Meaning that if I were to graph it, it would look something like this, right? It would not be symmetric on both sides. It'd be symmetric along the origin. Okay, let's do another one. I hope I gave myself enough room on this page to do it. So what I think I'll do is I won't write down the steps. I'll just show the steps, and then you know, but they're the same. So the next one says g of x equals x squared minus 2. But we're going to substitute that x for a negative x. Oops, sorry, I'm getting notifications. Okay. And so same thing on this side. The x becomes a negative x. And then a negative x squared, well, negative times a negative would just be a positive. Okay, so after we simplified this, we're going to do substitution. We're doing the same steps that we did up here. Substitute. Is there an x squared minus 2 anywhere that we could substitute with it? Well, there is. X squared minus 2, x squared minus 2, they're the same. But what equals the x squared minus 2 is this g of x. So in place of this, I'm going to substitute a g of x. Here we have a negative, or g of negative x equaling a g of positive x. So which one would that be? We have the negative equaling the positive. Right. That would be even, which is to say, if I were to graph this, the parabola would just be symmetric. Whatever was done to one side would be done to the other. Okay, let's do this last example here. I think I can fit it on this part of the paper here. We'll try. So we have h of x equaling 2x squared plus x minus 2. The first step is just to write the function. After you write the function, you want to substitute the x for a negative 1. See, that's what we did here. That's what we did here. It's always the first step. So negative x, negative x. So we're multiplying it by a negative 1. All the x's become negative now. There we go. Okay, after you do that, let's simplify it. Can we do any order of operations here? We can. A negative x squared is just x squared. Okay, the last step is substitution. So is there anything that's the same as this? Well, as I look, the closest we have is a 2x squared plus x. This is a 2x squared minus x. You have to look closely. Since they're not exactly the same, I can't do substitution. See how this is a plus and this is a minus x? This is a plus x. They're not exactly the same. So if I can't do substitution, that means I can't continue. I can't say this h of negative x is either a positive or a negative. So if it's not odd or even, what is it? Well, it's neither. It's neither, okay? Sometimes you get an equation that's not either odd or even. That's possible to do. So it's neither, okay? Well, so if you think about it, though, a lot of graphs are neither. They're not going to be a perfectly symmetric going this way on a parabola, or perfectly, or maybe I'll just get a graph real quick. They're going to be perfect symmetric going like this. They're not going to be perfect symmetric going across the origin. I mean, there's lots of shapes, for instance, like a circle, right? That wouldn't have all of those. So it makes sense that most would probably be neither, right? Okay, cool. Steps are simple. Let's try a few more, and then I want you guys to try some on your own. Let's do this one first, though. F of x equals 3x. Let's see what we get. So the first step, again, after you write the function, is to put a negative x where the x was. The second step is to simplify it. Is there any squaring we can do, any multiplication? I'll multiply these. Third step is to do substitution. I'm going to look for something that I can put in place of this here. We're keeping the negative, but we're substituting the 3x for the 3x here. And what does that 3x equal? It equals a f of x. So I'm not doing anything to this side. Oh, you may observe we really didn't do anything to this side the whole time after the first step. Just brought it down. Okay? And then since the 3x equals f of x, it's just a f of x, but notice there's a negative in front. So then we have an f of negative x equaling an f of a negative f times x. And what we see from our chart is when that happens, that's odd. So the answer to this is odd. Okay, let's do another one. Same steps. Instead of an x, we're putting a negative x. We're multiplying it by negative 1. Okay. You know what this forgot is the f of x in the beginning. Let's write that real quick. So it would be f of negative x equals, if we simplify this, a negative times a negative is a positive. So it would be a positive 2x squared minus 6. And then can we substitute this for anything? Yeah, this and this are the same. And since this equals f of x, instead of this I could write f of x. So we'd have a f of negative x equals, and since this and this are the same and it equals f of x, I'll use substitution, f of x. And so when you have a negative equaling a positive, it's even, right? When you have this negative f of x equaling a positive, it's even. Okay, last one I'm going to do, and then it'll be your turn. So same thing. Let's write the f of x here. So f of x equals this trinomial. Let's substitute a negative x in. That's all you have to do. Everywhere there's an x though, here and here. Then you just do the order of operations, right? So it's f, you're simplifying it. You would square a negative x times a negative x is a positive x squared. Negative 2 times a negative x would be a negative times a negative, of course, is a positive. It would be a positive 2x plus 4. Now, do we see this anywhere? No, almost here. But here you have a negative 2, and here you have a negative 2, and here you have a positive 2. They're not exactly the same. So it's not negative, it's not positive. This one would be neither. All right, go ahead and give this one a shot and see what answer you get. Okay, good. Now give this one a shot and see what answer you get. Good. Now try this one. Okay, now go ahead and do moms. Cool. I think we got this.